Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. Now, in today's video, we're going to look at May-June 2024 question paper, chemistry, okay? Physical science paper 2. All right, without wasting any further time, let's just dive into it. Now, it says to us 1.1 the functional group of aldehyde is now, this is supposed to be an easy 2 marks. Remember, carboxylic acid is for the carboxylic acid. Again, you can see carboxyl group, it's for the carboxylic acid. Hydroxyl group is for the alcohol. Then carbonyl is for the ketone. Okay, carbonyl is for the ketone. Therefore, the most correct answer is A, formal group. Okay, formal group is the correct answer. 1.2 1.2 says, which one of the following equation represents the reaction for the identification of unsaturated organic compound? Now, if you want to test for unsaturated compound, you have to undergo a process called bromination, an addition reaction called not addition reaction. Yes, I think it is an addition reaction called bromination. Bromination, in which an unsaturated compound, let's say CH2, CH, CH2, we add Br2 to it. Then it gives us something like CH2, CH, Br, CH2, Br. Okay, this is bromination. Let's look for that answer there. This one, it goes hydrogenation. Can we see that H2 it undergoes hydrogenation? This one hydrobromination. This one bromination. Okay, also this one bromination. But now the product should be the product should have Br, because remember, if it is an unsaturated carbon, unsaturated organic compound, it means it has double or more than a single bond again. So it means there are gaps in between. So it means whatever Br there should fill up the gaps. Let me draw a structure for this one so that you can see. It was like this: CH2, CH, then CH2, like that. Can you see now? This was short here. Okay, I think it's supposed to be CH3 here. Let me say CH3. Okay. Let me say it is CH3, like that, like that. H. Can you see that there are bonds that are left there? So that's when Br comes in now. Okay, this is what we call unsaturated compound, because now the other compound that is added to will suit exactly as it fits there. Again, yes, so C for now is the correct answer. Let's look at D, why it is not, because now this part, if you can draw the structure, it is a a single bonded structure. It is an alkane. Okay, so to prove bromination, you need an alkene or a alkyne. Okay, I believe you are following. 1.3 says to us, which one of the following is the empirical remember, empirical, it is the simplest formula. What again? Do not confuse this with the molecular formula. Molecular formula, it is the actual again of ethyl ethanoate. Remember, ethyl, it is something like this. Ethyl, if you were to draw ethyl ethanoate, uh, if I remember very well the structure there, let me see. This is ethyl there, then COOH. I think carboxylic acid should be somewhere in, I can't remember very well. Let me see. Is it like this? I'm not so sure. Ethyl ethanoate. This is the ester. Okay, so let me do this. Yeah, I think it's supposed to be like, is it the double bond here? Then let me do this. COOH. I think it's like this, if I'm not mistaken. Okay. Yeah, I think it's like this. But now the important part is that can you see that we have four carbons actually? So we have C4, four carbons, and I know the general formula for this one. It is CnH2nO2. Meaning if I have like forward four carbons like this, it means I'll have eight hydrogens, then O2 like that. Okay, now let's confirm. Hydrogen number we have one, two, three, four, five, six, seven, eight. Okay. So it means we have eight as I've predicted from the formula H8. Then oxygen, how many of them? Two. Okay, O2. But this is the molecular formula. This is the molecular. What is the empirical? Empirical is the simplest. So I can divide by how much here? By two, which is the simplest. Remember here it is eight. Okay. So when I divide by the simplest, it gives me something like C2H4O. Can you see I can no longer divide this any further? Yes. Any answer that has something like that, C2H4O, this one. So the most correct answer in this case, it is A. Okay. D was going to be the correct answer if they wanted the molecular formula. I believe you're following. Now, in an experiment, 5 grams of calcium carbonate reacts with an excess hydrochloric acid. Okay, so it means now a calcium carbonate, it is a limiting reagent at a temperature of 40 degrees. Okay, then here's our reaction, the off, forming carbon dioxide again, in a form of gas. Now, the volume of carbon dioxide produced versus the Oh, sorry. The volume of carbon dioxide produced versus time is shown by curve P in the graph below. So the reaction, this reaction is shown here by the graph of P. Let me redraw that like this. I'll only say this is the graph of P. I'll just do this. This is the graph of P, like that. Now they say now the experiment is repeated with. Let me do this. The experiment is repeated with 10 grams of the same calcium carbonate sample and an excess HCl with the same concentration. Okay, so they did not change the concentration. Okay, with the same concentration at 40 degrees. So the temperature and the amount of hydrochloric acid is still the same. Okay, it was unchanged. But now, can you see now that instead of using 5 grams, they used what? 10 grams. Now, if they use more reactant, so it means we are expecting what? More carbon dioxide. It means now they are increasing not the rate, they are increasing the rate at the same time they are increasing the what? The amount of product. I repeat, they increase the rate at which the reaction will occur will increase because now there are more reactants, and already the HCl it is in excess, and now carbon dioxide it is more. So it means more collisions per unit time. Okay, right? So it means the rate increases, and now also more carbon dioxide is formed, or more products are formed, because now we have more what? We have more of the reactant. Okay, so it means I said now, if I were to redraw the graph of this reaction that occurs now, it says now I'm saying the rate increases. If the rate increases, it does not start, it means it will start with a steeper gradient. Again, and again, what will happen is that it will form more. Remember, this is the amount of carbon dioxide formed again per time. Again, so it means remember more reactions, sorry, more collisions occur per unit time. So it means now the rate is higher, also the amount of carbon dioxide formed, so it is greater. So now let's check, what do they want? Which one of the following curves will now be obtained? I know, because now if you are saying I is the correct answer, can you see now that the amount formed, it is low, also the rate is slower. In your graph, if the rate is higher, if your gradient is steeper like this, just know the reaction is faster. But if it is like this, just know your reaction is slower. Why? Check. For the same time, can you see that it consumes less carbon dioxide than this one? Can you see that this one with the same T, it produced more carbon dioxide. Yes. So it means now it is incorrect. Let's look at I. I, can you see it starts with it? It starts with where with the same rate, and we agree that the rate will not be the same. Okay, even though it produced more, but can you check the rate now? Can you check the rate now? The rate, it is not correct. This is this one, incorrect also. Let's look at this one. Two, this one. Now, can you see now that, okay, the rate is higher, okay? But now the problem is that it ends with the same product, and that is not the truth. That's not the truth. The results are not the same. Now, the amount of carbon dioxide formed is not the same. Okay, this was gonna happen only if they increased, let's say maybe the temperature. If the temperature was an effect, remember it was gonna only affect the reaction rate. Okay, it was gonna be faster, but at the same time, the products were gonna be the same because the amount of calcium carbonate did not change again. So now this one is incorrect. Let's look at IV. Can you see that IV, it is low? Sorry, it has a higher rate than P. Can you see that higher rate than P? The gradient is steep, and can you also see that it forms higher volume of carbon dioxide? Yes. So it means now this graph is supposed to be what? Graph of V. So the most correct answer, it is D. I believe I explained that. Now, the balanced equation below represents a reaction at chemical equilibrium. Okay, so we see by the double arrow, meaning the forward and the reverse reaction occurs simultaneously. Now, two chromium oxide, or whatever they call this, plus 2 moles of hydronium ions, plus, yeah, that one, plus 3 moles of water. Now, so the reaction, when, okay, I want you to see these colors. This is how the colors works. Ne? If the forward reaction is favored, it means the color changes to orange. If the reverse reaction is favored, it means the color changes from this one to yellow. That one is straightforward, I believe. Which statement is or are true when a few drops of concentrated hydrochloric acid are added in the mixture? Now, HCl, this is a ion effect. What? Okay, remember, uh, they don't normally emphasize these teachers' name, but I'm gonna highlight this. When you are given something like this, HCl, you're gonna break it into its components. Now, the ion effect works like this. Between the two, only one of these will go to the reaction, if not both. But now you check your reactants. You check between this one and this one, which one can be added to which one, to whichever in this case. Can you see now there is no space for Cl in here? There is nothing that has Cl here. So it means Cl won't be used. But can you see H plus we have here? So it means now we will take the H plus and add it here. Okay, this is what is going to happen. We're going to add what? H plus here. If we had something with Cl minus what, it means we're going to add Cl. But in this case, we have H3O plus. So H is somewhere here. It is there, here, right? Cr and Cl are not the same. So now when they add, I want you to see this. When they add H, H plus to this hydronium ion, the concentration of H3, the concentration, let me do this. This is the concentration, right? The concentration of H3O plus will increase. But now, that is not what we want. Okay, we want all our things to be at equilibrium. Okay, so now if this one increases, so now Le Chatelier and the equilibrium will want to do what? Will want to decrease this amount of H3O plus. But how can they do that? By transferring them to the other side. The only time they can do that, it is by transferring them to the other side, the concentration to the other side. Okay, but now I want you to see something. If the concentration is shifted towards the right hand side, it means now we are decreasing the amount of H3O plus concentration again. So it means now if we are favoring the forward direction like that, as I've said, Le Chatelier will want to move in the opposite direction, or the direction that will try to minimize this increase. It will be the forward direction, right? And if the forward direction occurs, what will happen to H2O plus? the concentration will increase. The concentration of Cr2O2 minus 7 minus, it will increase. But now our reactants, since now are being used, they will do what? They will decrease. So this one was only the effect. Again, this was the effect. But after the effect, what happened? They decreased because now they are reacting to do what? To transfer excess hydronium ions that were added there to the other side, and then now these will increase because now they are being formed more of them again. And now can you see if the fourth reaction is favored, it means now our reaction will turn from yellow to orange again. Yes, so now let's look at the most correct answers thereof. The reverse reaction is favored. This is a lie. If we favor the reverse reaction, it means now we are increasing H3O plus more, and that's not what we want. Okay, the concentration of Cr2O7 2 minus increases aqueous. Is this true? Yes, it's true because now the fourth reaction is favored. It means they are favored thereof. The color of the solution changes from yellow to orange. That is true because it is moving from yellow to orange. But the chemistry is so beautiful and nice in terms of conditions. 2 and 3, it is D. So the most correct answer is what? D. I believe you are following. I strongly believe you are following. 1.6. Consider the equation below for a hypothetical reaction. Okay. Now remember, this is a chemical equilibrium. Sorry, chemical reaction. Okay. And now we know for the equilibrium, when you do Kc expression, which is the product divided by the, this is just a general. There has no mark basically. These are the conditions. Conditions. These are the conditions. When you substitute here into Kc formula, no liquid, no liquid, no solid, no solid. Okay, we only accept aqueous and gas. Okay, so first thing first, before we even go to whatever equation, okay, let's see if the equilibrium constant Kc is 1 times 10 to the power of negative 4. Can you see that 1 times 10 to the power of negative 4, it is the same as 0.000, sorry, 0.1. So can you see that our Kc in this case, it is less than, sorry, Kc is less than 1. And if Kc is less than 1, it means now the amount, if this is less than 1, it means it is less. So it means since well it is directly proportional to the product, it means our product will be less and our reactants will be high. But now, before I go anywhere, in our in the expression here, I do not expect to see B. Why? B, because it is a solid and we do not accept solids in the condition of Kc. It means this one I'm not expecting to see. Anything that has B, I cancel it. Okay? Now I'm saying Kc is less than 1. So it means now my Kc expression is gonna be the product which are C multiplied by D all divided by A. Okay, but now my Kc is low. If my Kc is low, it means now my my products are low, also my reactants are more. So it means now A is greater than the combination. The concentration of A, it means now it is greater because it is higher than the what? Than C and sorry and D. Which correct answer is that? C is the most correct answer. Okay. Which one of the following shows the product of reaction between oxalic acid, which is an acid, as well as sodium hydroxide, which is a base? Now remember, a combination of acid plus base. The result will be salt plus water. So anything that has carbon dioxide, it is wrong. But now the question is between B and C, which one is the most correct answer? Now oxalic acid is a very, very strange acid. It has something like uh, if I'm not mistaken, something like 2 minus, or yeah, it has something like this, if I'm not mistaken. Okay, then you add it with a sodium hydroxide. So now what happens is that in this reaction, the when we remove the C like this, it's gonna be COO2 minus and H plus. Okay, H plus, because H it is a positive ion, right? Now it's gonna be added to Na plus and OH minus. Okay, but can you see now in a reaction the plus will want to combine with the minus, these signs. Okay, so it's gonna form us what? H2O. But this one, COO2 minus, is going to want to combine with Na, but they are two. It can acquire two Na. So it means now our Na should be two of them. So it means we'll have COO2 Na what? 2. Can you see that? Because these two will come down there to Na, and Na will acquire, will have 2 moles of it. So it is something more or less like that. Let's look at our equation and see which one is that. So can you see that this one? No. C it is not. C it is a reaction of this one. Okay, plus NaOH. It was gonna be correct if it was this. Okay. I think that one was ethanoic acid or what. So the correct answer is B in this case. Okay. Please know the formulas of your acids and what. Sometimes they can catch you off guard. For solution of different acids of the same concentration. So now, if the concentration is the same, now it means we'll have to check if it is weak or strong. Which one of the following Ka values represents the weakest acid? At now, remember weak acid. For weak acid, the Ka value it is less than 1. For strong acid, the Ka is greater than 1. But now, can you see that all of them are less than 1? Because now -2 means now it is point zero something. But now, which one is the weakest? The weakest has the most negative exponent. Why? Because it is 0.00000, say 6. Say 6. This one has 5, 0.00005, 0.002. Yeah, something like this. We can you see that this one is more or less. So the most correct answer is A here. That one was straightforward. 1.9. 1.9. Copper is purified by electrolysis. Remember electrolysis? It is the one that says to us at cathode it is negative, and anode it is positive. Remember, unlike galvanic cell says to us the cathode is positive, the anode is negative. Okay, it is vice versa. And always note sometimes we form at the cathode. Okay, so if there is something that we want to form, we'll form it at the cathode. Okay, which one of the following combination is correct for the changes occurring at the anode, cathode, and in the electrolyte when the cell is operating? So I just said this one is positive. Again, this one is negative. Okay, and here we have Cu2 plus SO4 minus. If this electrolyte now we we break it, right? Now what will happen is that we want to form. Okay, we want to form. Now I say we form at the cathode. So we are expecting this. Remember, we're trying to purify what? Copper. Again, so it means this copper will come to these, to the cathode, because we are trying to form it here, right? But now there will be some copper here that will be released, okay, to balance out, this copper that is released here, okay. So this copper will go to the cathode, but there will be some copper here from the anode that will be released to our solution thereof again. Then SO4, remember, is if it releases something, it will be left like this, positive like that. So SO4 minus should come and try to balance the charge. Okay, the minus will come to balance the what? The charge. Okay, because this C2 plus it goes to the minus. Can you see that? And remember, if you are forming at the cathode, it means now the mass of the cathode will increase. Okay, it means now we have copper maybe here, copper. Actually, here it is copper. Okay, sometimes they put at the cathode, they like to put maybe a spoon. They say they are trying to galvanize what the spoon with copper or gold. So the spoon will be here at the cathode again, whereas copper is purified here. It releases the CO2 plus. It releases the CO2 plus. Now they go where? To the cathode, because now they are being formed again. So it means here something like oxidation occurs. Okay, oxidation occurs here, and now reduction occurs here. But now remember, as we are forming at the cathode, now it means the mass will increase, because now it will be the cathode, whatever it is in there, plus the copper that we are trying to purify again. So, but in here, the copper that we want. So it means here maybe it might be something like copper with zinc and silver. So we are trying to get what we want, which is what? Which is copper in this case again. Yes. So this one will decrease, because if we take copper now, we are left with zinc and silver. So it means the mass in here will decrease. But now what will happen to the color of the electrolyte? The electrolyte in here. Now the color will not change, because why? This copper is taken to the side, right? But now can you see that this one release copper 2 plus to the what? To the water, so that it can balance out the copper 2 plus that went to the cathode. Your net will release it to the electrolyte there, our liquid there off. Okay, therefore it means now the most correct answer, mass of the anode will decrease, mass of the cathode will increase, no change, no change. So the most correct answer, it is in this case B. Okay, it meets all the requirements. Sorry bana ba heso, it is B. 1.10, which one of the following redox reaction is spontaneous under standard conditions? Now, if it is spontaneous, it means whatever this one, when we check this one, like if I have Br2 in a reaction, maybe this one will want us to look at the standard reduction table. We look at it again, Br something, then the Cl should be something like Cl there, and with some other stuffs there. So okay, so now it means from Br2, the one that we start with, Br2 to Cl minus, the gradient should be positive. This is when you use table 4b. Okay, this works for table 4b. Br is going to create a spontaneous with Cl minus. If this is spontaneous, it will do this. If it is non-spontaneous, what you start with, let's say copper, it will be copper, then some other stuffs, then here it will be Pb2 plus, and some other stuffs. Can you see now it creates a negative gradient from here? Sorry, from here to there, it is a negative gradient. It is like this. Oh, now we want that. Okay, so if you apply that there, you will see that now, if I look at number B, which is the correct answer, Fe3 plus. So I want to look at Fe3 plus. Never mind the 2 for now. Fe3 plus, that forms Fe2 plus. Let me look at that. Fe3 plus, that forms 2 plus. It is this one. So I wanted this one. Okay, I'm focusing on this one. And now with what? With I minus, that forms I2. And I minus should be in this side, so that it becomes beautiful like this again. So I minus, it is like this. Can you see now? Here it is I minus and I2. So it is here, this one. So can you see it forms something like that? So it is a positive one. It is a positive one again. Now if I were to look at B, this one, maybe A. Let's look at A. Br2. Where is Br2? Br2. Br2, here it is again. Here it is Br2, but now it is reacting with what? Cl minus. Where is Cl minus? Can you see now? Here Cl minus, that forms Cl what? Can you see it gives me a negative gradient? So this is non-spontaneous, whereas this is spontaneous. You can also check with the others. They will give you non-spontaneous. Okay, so yes, that's all for our multiple choice questions, folks. Thank you. I hope you enjoyed a review of chemistry. Let's meet on question 2. Okay, nomenclature. Thank you. If I did any mistakes, please leave them in the comment section. I'll attend to them. Thank you.